Draw a circle where?
Put point B right there at the angle.
Right here?
Yes.
Okay, so we have point B.
So what would you say? Draw a circle. Centered
Yeah.
at point B?
Beautiful
Yes.
handwriting. Or computer writing. I don't know how you said that.
Does it matter what size the circle is?
No, because it's right.
Alright, Dakota says it doesn't matter because it's a ray.
You're totally like messing up.
I'm not messing up. Alright. There's the circle centered at B. Now what?
When the circle meets both rays.
Draw a circle where
Shoot your mouth. Mark.
Choose points
A and C.
A and C
Where the circle meets the ray.
where the circle meets either ray. So that would be here and here. Okay, now what?
Then draw
Oh.
a circle centered at A with a radius AB.
Draw a circle centered at A
Yes.
Radius AC.
with radius AC,
AD.
AD,
AB.
AB.
Yes.
It might not matter.
it might though.
It might not matter. So I'm going to make the circle this big.
No, it does matter.
It does matter.
It needs to be A to C.
I don't know. I think she knows what she's talking about. I'm gonna go with her wherever she's saying.
No, you're wrong.
You're wrong. We done.
Yeah.
Make a circle.
With a radius AB.
It's AC.
It's AB.
I don't know.
It's AC.
It's so easy.
It's AC.
Okay, what was your next step?
Draw another
Draw a
circle on
circle.
C centered at C.
Draw another circle centered at C. Does it matter how big that circle is?
Yes.
What size does it need to be?
Radius BC.
No, you. You're so.
I am so wrong.
Actually.
What do you think? Do you think I'm so wrong now? Huh? What
You're
now?
not wrong.
Wait, so that's
My version's easier to explain.
No, it's not.
Yes, it is.
Wait, why is that? Why would you draw that if it's not right? She's going off with the
No.
It is right.
That
is right.
It is right.
Easier to explain my way.
Alright, let him explain it.
Why is she?
Now what?
I got it right here.
Now find the point where the two circles intersect. And name it.
But then don't let me see it.
Be quiet, take that fraction.
All right, which intersection?
Circle, man.
The AC.
Inside the angle.
Circle A and circle
You had
C.
so many circles on this paper.
Circle A and circle C.
All right, now what?
Draw your
Draw
line.
a ray from B to D.
Connect line. Connect dots.
Oh,
Ray BD.
Mm-hmm.
What do you think? Is that right?
Yes. Looks pretty right to me.
What were we supposed to do here? Bisect an angle. Find the bisector BD. What does bisect mean?
cut in half.
The ray that divides an angle into two congruent halves.
All right. So the last step of our explanation, or the last reason in our explanation, needs to be that this angle, ABD, is congruent to this angle, DBC. All right? So we need to say angle A, don't make fun of my writing, B, because I can't do the angle symbol, D, is congruent to angle D, B, C. That's the last part of our explanation, because that's what it means to bisect an angle. Did anybody have any ideas on explanation?
Yes.
What?
You use. Oh, you
He said he's not telling.
CPCDF, something like that.
CPCFC?
Yeah.
You will use CPCFC.
What does that mean?
What is that?
CPCFC says
Two congruent
corresponding
Congruent
parts
figures
of
are
congruent figures
Are
are congruent. Now, before you can use that, you have to have congruent figures.
Side angle side.
Before you can use CPCFC, you have to have congruent figures.
Won't you use axiom 3?
You won't use axiom 3, but you will use axiom 2.
Why
What?
don't you use axiom?
Can you tell me anything that's congruent here?
BC and BA.
Okay, so BC is congruent to BA
By definition of
by definition of radius. They're both radii of the same circle. So we've said that this segment is congruent to this segment. All right, what else can we say?
Why can't you do that?
Why can't it be this easy?
Why can't you be axiom 3?
Did you put AC as
axiom 3, isn't that side angle side?
AC, what would AC be congruent to?
BD is congruent to BD.
BD is congruent to BD. Why?
Because it's two halves.
What do you say when things are congruent to themselves?
I did.
Corresponding.
I did.
Axiom 1.
Reflexive property. Do y'all remember that a while back?
No.
Reflexive property. It's on the board.
I caught it. I did.
Do you see that?
Okay, Missy,
Not yet. All right, look. This segment BD is congruent to itself. Anything is congruent to itself. It's called the reflexive property. So what we're looking at right here is we're looking at this triangle BAD. Do you see that triangle? And we're looking at triangle BCD. All right, we want to show that those two triangles are congruent. So we have the first set of sides that are congruent, AB and BC. Now we have the second set of sides that are congruent, BD and BD. They're both part of that triangle. What else can we say is congruent?
AD is congruent to CD.
AD is congruent to CD. Why?
Definition of radius.
They are both radii of congruent circles. They're not radii of the same circle, but the circles that we use to make them are congruent, so they can be congruent. So we've said AB is congruent to BC. We've said BD is congruent to BD. And now we've said AD is congruent to CD. So what does that mean? What does that mean about those two triangles?
They're both congruent.
All right, so triangle, what?
ABD.
ABD is congruent to
CB.
triangle,
DVC.
it's got to be in the right order,
CBD.
CBD. Why?
Because it's
By
X.
axiom 2.
Side.
Side. Because we listed a pair of sides, a pair of sides, and a pair of sides. So now we can use side. And I'm going to put the little triangle symbol here. Triangle ABD is congruent to triangle CBD. All right? Now we're still not done. Remember, our last statement needs to be about these angles. Now we're ready to use that thing that you talked about a second ago.
Axiom 3.
Not axiom 3.
CD.
CPCFC. What can we say about it?
They're corresponding.
We have this triangle, ABD, congruent to this triangle, CBD.
They're corresponding figures.
They're congruent figures. What are their corresponding parts?
B. What? BD?
BD is a corresponding part, but it's not one that we care about.
AC.
We care about this angle and this angle. Are they corresponding? Yes, they're corresponding parts of congruent figures. So what does that say about this angle and this angle? They're congruent. So we have angle ABD that's congruent to angle DBC by corresponding parts of congruent figures are congruent.
CFC. I told you it had 3 C's. It had 3 C's.
All right? Therefore, ray BD is a bisector of angle ABC. Boom. It is not too much work. It is just thinking.
Seconds will seem break if I like shake it.
Yes.
Okay.
I mean, why would you?
You would know if it was